So section 1.5 is all about complex numbers. To understand complex numbers, you first need to have a good grasp on what an imaginary number is. Imaginary numbers are numbers that involve the square root of a negative. So for example, square root of -1, square root of -4, square root of -5, and square root of -7 are all called imaginary numbers. The imaginary numbers are based on the imaginary unit little I, where I squared equals -1. So that's one way to memorize it, and you will need to know that I squared equals -1. But little I is simply defined as the square root of -1. So if we have, for example, the square root of -1, what do we know that equals? I. So you will never leave the square root of -1 anymore. You will always replace it with I. The square root of -4 equals what? It's the same as I. The negative comes out as an I, square root of 4, which is I times 2, which is 2I. So square root of -4 is 2I. Now the square root of -5 is what?
Plus or minus I square root of 5.
It is I square root of 5. You technically don't put plus or minus unless you introduce the square root to the problem while you're solving an equation. So plus or minus is kind of something that just goes with solving the equation process when you introduce the radical. And square root of -7 is what? I square root of 7. Now, some books put the square root first and the I last. I think this book puts the I first, I square root of 7. I think it looks better that way. Plus, it's obvious then that the I is not under the square root. The I is not a part of the square root. It goes out in front. Now, here's the problem a lot of people have trouble with. If A and B are both negative, then the square root of AB is not the same thing as the square root of A times the square root of B. Now, the way that's written is said a little funny. I think it makes more sense to people if they look at the example down here. Right here, it says the square root of -16 times the square root of -4. You are not allowed to just multiply that together and say that that is the square root of 64. That's not the square root of 64. This right here does not equal the square root of 64. The square root of 64 would equal what? 8. That is not what this equals. When you have two radicals multiplied together and they're negatives, you need to take the negatives out before you do anything else. So instead of going further right now, you need to go ahead and say that this is what? Square root of -16 is I square root of 16, which is 4I. So that you can actually go ahead and simplify to 4I. And the square root of -4 is 2I. And then once you've kind of cleaned those up and taken the i's out, now you can multiply them together and say that 4I times 2I is 8I squared. And I squared is the same as what? -1, which is -8. So see, if you try to multiply them before you start simplifying, taking the i's out, you'll get +8. But we know that the answer is actually -8. So be really careful with that as we start to work through these problems. Complex numbers. A complex number is a number that can be written in the form A plus BI. Now, it doesn't have to actually be plus. It can be plus or minus. The B could be negative. Where A and B are real numbers and I is the square root of -1. So I is the imaginary unit. The number A is called the real part and the number little b is called the imaginary part. So here are some examples of complex numbers. -2 minus 5I. For that imaginary number, which part is A? -2. -2 is the real part, so that's little a. Which part is B? -5. Yeah, B is the number in front of the I, so it's -5. Now, technically speaking, any number can be written as a complex number. For example, the number 7. That's just a real number. Doesn't have any imaginary parts with it. It's not, doesn't appear to be complex. But if I write 7 as 7 plus 0i, now technically I have to consider it a complex number, where the real part is 7, but the imaginary part is 0.
Yeah.
Likewise, if I just have the number 2i, that looks like it's purely imaginary, and technically it is, but if I put a 0 in front of it,
It's just complex.
now it looks like a plus bi, but the a part, the real part, happens to be 0. So don't get all stumped on the words complex number. If someone tells you just write it in the form a plus bi, all that means is they want you to put the real number first if it has it, and then add or subtract the imaginary part from it after that. You don't ever want i's to come first. We wouldn't want to say 3i minus 7. We would rather write that as
Negative 7
negative 7
plus 3.
plus 3i. Right. So that would be the proper way to write a complex number. Here's our first example, and I think it actually is one of the ones that causes more trouble for students in this section. It says, to find the numbers x and y that will make 3x plus 4i equal to 2y plus x plus xi. I'll give you a second to absorb that. Okay. So we're going to take the real part and set it equal to the real part, and the imaginary parts and set it equal to the imaginary parts. For the left side of this, what is the real part? 3x. The real part is the part that's not attached to the I. So the real part on the left is 3x. So we want to set 3x equal to 2y plus x. We want to set the two a's equal to each other. So 3x must equal 2y plus x. The problem here is there are two variables, and I can't solve that yet. This is where I set the a's equal on this side. Let's go now and look at the other. Let's look at the b's. What are the b's for these?
4i.
Okay,
Do you
so
bring
on the
the
left
I?
it's 4i and on the right it's xi. But technically b doesn't contain the I. The I is separate. B is just what's in front of the I. So we just take the 4 and set it equal to what? X. So that helps us a lot. Now that we know that 4 equals x, I can come over to the other side and substitute 4 in for x and see if I can figure out what y is. So sometimes you actually have to work on the b's before the a's here. So on the left, I know that 3 times 4 is 12. And that has to equal 2y plus x. And I'll substitute 4 there as well. So 12 equals 2y plus 4, which means that 2y has to equal what? 8. 2y has to equal 8. So 1y must be 4. So those are the two values of x and y that we could substitute in here and would make those two complex numbers equal to each other.
So use the x value that the imaginary side gives you.
Right.
To the real side.
Right. So you just set the a's equal to the a's, the b's equal to the b's, and then you solve for x and y. Example 2 just asks us to simplify these two problems. Let's start with part A. Part A says take 3 plus 4i, so that's one complex number, and add to it 2 plus 7i. So 3 plus 4i plus 2 plus 7i. What's the operation here? Add, subtract, multiply, divide.
Adding.
Adding. When we add, do we have anything to distribute? No, we don't have anything outside of these parentheses. So are the parentheses necessary?
No.
So we can just drop them? Let's drop them. So we have 3 plus 4i plus 2 plus 7i. For a grand total of how many real numbers?
5.
5 real numbers, and how many imaginaries?
11.
So 5 plus 11i. And that's part A. Part B is a little trickier, and someone always misses it. It does not matter, someone always misses it. Never fails. What's really odd to me is when people miss these two problems, they try to foil them. They overlook the addition and subtraction sign, and they try to multiply them together and turn it into this really complicated thing. And really, you just have to be very careful. Not every time that you see two parentheses are you being asked to FOIL. Sometimes you're just being asked to add and subtract them. On the left, we were being asked to add, but on the right, we're being asked to subtract. Now, with a subtraction problem, the parentheses are important because before you can just drop the second parentheses, what do you have to do?
Distribute negative.
them negative.
Distribute the subtraction or the negative sign. So the first one, we can just drop the parentheses, and we have negative 5 plus 8i. But the second one, we have to distribute the minus to get minus 2, and a minus onto a minus gives us
Positive.
positive 12i. Once we distribute the subtraction, get rid of the parentheses, then we can combine our like terms. Negative 5 plus negative 2 is negative 7, and positive 8i plus 12i is positive 20i.